Good morning. Good morning, everybody. Good morning. This is Suraj Singh speaking from Bharat, India on this day, December 13, 2021. Minute 4:15 a.m. After efforts of more than 35 minutes, I could get some signals. I tried many times, but I lost video again. Signals are down. I don't know whether it will continue just 30 minutes, 30 seconds. Signals are down. I don't think it will continue, but what to do is wasting my time and just recording for nothing. It's 00 video and 00 audio. Something has come, but frame rate is very low. I don't know what's happening. A waste of time. Just no below bloody Airtel. Bloody Airtel, I should say. Topic is civil field engineering, engineers, concrete specifications, quality contracts, etc. As usual, we talk about this. And in last video, I have shown my certificates. Now I was talking about quality, about telecommunication, and you can say about something that's very important in life. And of course, talking about communication coordination, I try to explain that one. That's very important in our world of engineering, without which we cannot do anything. Without communication and coordination, we stand nowhere, and that's our requirement. If communication coordination don't stand everywhere in engineering, these are required everywhere, even in designs or in pre-design or in construction or in sites or in dealing or in contracts. So you can take whatever, every detail is required, and that the detailing is very much important. If we don't have that detailing capacity, we cannot do engineering. Not only engineering, every work where quantity is required, where quality is required, where coefficients are required, where formula are required, wherever something is required, communication and coordination are very important. When you do design work, we have to think of everything. We cannot simply say we have done it. Simply thinking and doing is not enough. We have to, you can say, think many times. We have to think also what's our objective, what do we want to achieve. अगर हमको अचीव क्या करना है यही नहीं पता तो हम क्या काम करेंगे. And what is our dream? It is scientific dream, it's not natural dream. You have some picture in mind. I'm not saying computer shall give you. First we have to have our own picture in mind, and that picture tells us what I have to do. And in engineering particularly, when we have to create objects, when we have to do projects, and projects come only after dream. Project is nothing but dream realization, you can say. I got some dream, I have to realize that. From vision of dream, from picture of that picture in my mind to real world, we have to deliver that picture to real world, and that picture is delivered through projects. That project can be design project, construction project, either design or construction or manufacturing, you can say. Many trials are made within these stages. Many hypotheses are used, many theses are used, or you can say many already created formulas are used, available theorems are used. There is nothing that cannot be used to deliver that objective, because in construction, in engineering, in design and development, every project is unique. We cannot copy these projects. Even if we desire, we can copy maybe something. We cannot copy everything, because every project is located differently, and we have to think about that. We cannot simply say, okay, we have this or we have not this. That's why I'm saying that sometimes we have to be very careful. We have to understand what is world of communication and coordination. Communication is my fundamental right in profession, without which I cannot do my duty. Though sometimes we communicate, but we don't even understand we are communicating. Sometimes we coordinate, but we don't understand we are coordinating. So we can say we have to extract these two, communication and coordination, from our minds and use them knowingly that this is part of communication and this is part of coordination. We should understand these two. In current age, it's very important because standards of communication have fallen, standards of coordination have lost their structure. People just use verbatim, they use only talks to solve all problems, and talks can never be recalled, talks can never be retrieved. We can retrieve documents, we can retrieve, you know what I say, we can retrieve records, you can say written document, we can record part of design is drawing of whatever. Without drawings, work cannot be done, and drawing is a universal language. When we draw a line, it's for everybody to know what it is. Every drawing, of course, there is notations on drawing that can be in whatever language. But drawing lines, points, circles, squares, or whatever is there, front, types, whatever is there, that is understood by everybody. So we can say drawing is like very top class communication language, and usually we call that drawing is a language of engineers. This means drawing is language of engineering, and of course then if it is language of engineering, it is language of humanity, because when we see some sketch, some drawing, and we understand that, we may not understand same thing if it's completely described. So it's part of communication. But drawing can be correct only when everything is looked into, everything is cared about. If you want to draw a square and one corner doesn't mean, how can you say this is square? Same thing we say, we have to achieve quality in whatever object, we have to understand what we have to do, we have to understand how we have to do, we have to understand from where we have to do. Means we should have all the requirements, only then we can do it. This means requirements. Then we have to understand what are requirements, and those requirements are actually very descriptive. There is no one requirement exclusive. There are so many requirements. On every requirement or sub requirement, there are so many factors which come in there and focus, and they decide what should be right, what should not be right. Sometimes we have many suppositions, assumptions, but every assumption or every supposition cannot be elected. We have to find a combination of various ones, and that's where coordination comes into play. We do construction, and before we do construction, we do designs. And before we do designs, we do conception. And that conception means it's a dream. Conception means it is something we have not seen, we may see, but our mind sees that, our soul sees that. But my mind and my soul cannot be shown to others. And that means it is a way through medium, and that medium is based on communication, that is objective, and that is objective is design, drawing of design, both. And once we bring it to papers, it's called the project. I started a project that time because paper was a scratch. It's completely scratch, and I started some object on that. And from there on, what you can say, it comes into physical being. Until something comes onto paper or whatever, paper is also computer. Something which comes in my mind, and then I have to transfer it to some medium or some page. It says that it enters mundane world. My mind produces something through communication of my soul and my mind onto some medium, and that is paper or computer. Then you can say something has entered into this world. That's called mundane world. Now I have to start from there itself then it comes in design portion, it comes in construction portion. All these two major, you can see, construction and design, or design and construction. And design also starts from origin, that means initiation, that means feed, and before feed रिक्वायरमेंट, ओरिजिनल रिक्वायरमेंट. ये सब चीज़ें हमको पहले समझना चाहिए. आखिर हम इंजीनियरिंग क्यों कह रहे हैं? इंजीनियरिंग खाली का काम करने को कहते हैं, इंजीनियरिंग खाली के डिज़ाइन को कहते हैं. इंजीनियरिंग एक सोच है, इंजीनियरिंग एक थिंकिंग है. वी हैव टू कंसिडर दैट इंजीनियरिंग इज अ थिंकिंग. इट्स ओपिनियन, इंटरनल ओपिनियन. It is something that we want to gain, but we do not know what we want to gain. You cannot imagine something and that same way you have to construct it to produce it. We cannot produce directly something and then we will think over this. Is it possible? No. I want to make one building. I have to think of something. Of course, it is very twisted one. It is very wrapped. It's very, stimmering. But I get some idea. Or we get some idea from previous projects. But why should I worry about previous projects? We have to think, I want to create something unique that has not been created so far. That's only intuitive, you can say. God sent, you can say, or something you never even think of. And while you start thinking of that is original thinking, that is original communication, or you can say pre-communication. And engineering is that. People may not know, those who are not from civil engineering, that we think a lot when we work in designs, and before designs we work something else. A kind of theoretical world. You may call it theoretical world, or you may call it imaginative world. Imaginative but scientific imagination. That's not physical imagination. There you calculate something without calculation. You calculate something without calculator. And we reach something, very preliminary stage at that time. And we write something, we think something, mind keeps on working, it works very fast. If people are engineers are experienced, they think of what sort of building I want to have, what sort of structure I want to have. And gradually move towards that, and ultimately, the complete picture is made in mind, or whatever comes in mind we bring onto paper. Then whatever amendment comes to mind, we could do it. And some stages are covered. Before design, I'm saying, it's kind of a dream, you can say, or you can say it's kind of conception. And that is where intellect lies in. After that, we have to work on that. That's operation on that. There's research on that, what we already have. And here is super quality of communication lies. When I say quality, this also applies to communication. Maybe you are surprised on this. But communication should be qualitative. When you are communicating to yourself, maybe it is different. Communication to myself, that's also important. People may say, what you're talking? No, communication is the first to yourself. You are communicating to yourself using your ergonomical studies, ergonomical values, our mental state we use, and that communication is very constructive. It should be. It cannot be destructive. So quality in quality itself, you can say, quality in communication itself, because communication can never end. And communication combines together many informations combined together to lead to coordination. Then it can be 2 information, 3 information, 50 information, 100 information. All these have to move together if they are synchronized. And if they are not synchronized, then you can say they won't move further, come out separately, and whatever moves together, whatever informations move together, they shall be group of coordination. So that is called coordination. Many items move together with certain relation to each other, and if they are not relative to each other, they fall apart. You try to understand my definition. It is a scientific definition. Maybe it's not defined in books, but we have to make it scientific. Only then we can understand. We cannot simply say talking. So talking is no science. thinking of one item and same time thinking of another item, and of course same time thinking of third item, fourth item, fifth item in sequence or in whatever way. Automatically they will form their sequence in hierarchy. Otherwise you cannot think further. You are trapped, you are interrupted, and once interruption is clear, all these items shall move together and flock. They shall, like birds flock, they'll flock together, and that flock is coordination result. You have to understand this point. It's very, very serious topic, very serious topic of coordination. And because I have done coordination on many projects, I understand how many problems do exist, how many difficulties are experienced, and it's not easy. And it's not easy because coordination requires communication, and communication requires concentration, and concentration is very difficult to achieve. एकाग्रता को प्राप्त करना बहुत मुश्किल है. एकाग्रता को प्राप्त करने के लिए आपको तालमेल बिठाना आवश्यक है. अगर आप तालमेल नहीं बिठाते, बहुत सी बातें होंगी, बहुत सी इन्फॉर्मेशन होंगी, आपको उन सबको एक साथ लेकर समझना होगा, पढ़ना होगा, सोचना होगा. अगर आप में सोचने की शक्ति नहीं है तो आप फिर भूल जाइए कि कम्युनिकेशन और कोऑर्डिनेशन से आप काम ले सकेंगे. देखिए, ये काम लेना होता है. कम्युनिकेशन से भी आप कम्युनिकेशन को मजाक में नहीं ले सकते, क्योंकि कम्युनिकेशन इन्फॉर्मेशन है. उसके लिए आपको एक सोर्स चाहिए, एक मीडियम चाहिए, और वो मीडियम रिकॉर्ड होता है. वो मीडियम ही रिकॉर्ड है, वही आपको बताएगा कि आपने उस समय क्या काम किया था. और उसको ट्रेस करना, उसको आपस में मिलाना, वो बहुत ज़रूरी है. अगर हम उसको नहीं मिला सकते तो ये शायद हमारी गलती होगी. और इसीलिए कह सकते हैं संचार माध्यम या तालमेल माध्यम, दोनों के साथ आपको चलना होगा और दोनों को साथ चलाना होगा. अगर आप वास्तविकता में इंजीनियरिंग करना चाहते हैं या जीवन में कोई भी काम प्रोफेशनल वे में, इंजीनियरिंग वे में, क्वालिटी वे में करना चाहते हैं, आपको इन दोनों को यूज़ करना होगा. यह आपको यूज़ ना करें, आप इनको यूज़ करो. होता क्या है कि हम यूज़ हो जाते हैं स्वयं से. जैसे कंप्यूटर है, कंप्यूटर को यूज़ करना हमारी ड्यूटी है, कंप्यूटर द्वारा यूज़ किया जाना नहीं. इस बात को भी समझना होगा. सांस हम अपने शरीर को चलाने के लिए लेते हैं, शरीर सांस नहीं चलाता. बात को समझना है. आई रेस्पिरेट, आई ब्रीथ फॉर longevity, for function of my body. It's not my body that functions for respiration. Try to get this point. If we use feet to walk, we don't use head to walk. We use feet only. Head is something you cannot use for walking. Same way, we have to walk using a stick of communication and stick of coordination, and these sticks are very strict, you can say. This can be vested, this can be drained out very easily. These both powers, I can say power of communication and power of coordination. And those who have power of communication, they are very rich people, rich in sense of, not in sense of money, but in sense of character, in sense of efficiency, because communication and coordination is required from childhood itself. You cannot understand anything if you don't have capacity to have good communication and good coordination. I sometimes think on this. I don't know why there is no subjects included in our studies that they should tell what is communication. Because we do it, but we don't formalize that. We do coordination in every activity in life, but we don't formalize that. And we do it, we use it, but because if you formalize at that state, it becomes a part of research, it becomes a part of innovation. We use them, but we don't know them. Likewise, we use our bodies, we don't know full mechanism of our body. It's same way. In engineering, there is no other way. In engineering, without quality, and quality means qualitative communication, qualitative coordination, qualitative information input, and qualitative use of that. Sometimes we say your description is very much, it's extensive. Just give us precise that. And if it is precise, we say just point it. Just give to one point, and we can say this is a point of order, just like people say this is a point of order. That point of order is real order. And there may be other points of order in that point. We have to see point of order. When there are many points of order are available, this means communication is available. That is referred one. Then this for us, for my use at that time, that in working out that problem. That is where we have to reach. If we want to do some work in a professional way, this is only way. First of all, if we want to use communication, we should have information. Do we have that information? If we don't have that information, then we cannot communicate other than hello and how are you. But when we have information, we don't worry about hello and how are you, but we come to point and say, okay, let's talk on this. Let's talk on facts, and we then deliberate on that. That's where, I'm not trying to explain what is communication, but I'm trying to explain how does it work. Communication works in very professional way, in very scientific way. People talk hours together on telephone, on mobile, but there is no meaning, only chatting. I'm not interested in chatting, because chatting does not give anything. It is chatting of engineering science, I can say. I have to chat about engineering science, about other sciences, and that chatting is very difficult. A person with having highest level of qualification has capacity to chat properly, because that requires highest functioning of mind, highest functioning of your power. If my mind does not function properly, I cannot chat. So what I say when I say quality in construction, quality in production, in manufacturing, in services, in education, in society, in individual, and quality in communication and coordination. We have to get these facts in real world. If you don't have these capacities, first of all, quality in society and individual, many times I have spoken about this, but fact remains that every time I come back to it, because of something else comes into mind. I have seen there was a time when people did not understand all this, but people were sincere, professionals were sincere, others were sincere, students were sincere. They had some fixed targets, everybody had some fixed targets. But now target identity has changed. Only one target among 98% people remains, and that is how to make money. How to make more and more. You mean to say that you must have material world. We are interested, even through sciences, through engineering, or through other professionals, how to make more money. That is our objective, and which is rubbish one. Which is really rubbish one. It's not scientific, it's not natural, because we have changed our objective, we have changed our track. And when we just live for money, then communication and coordination world disappears. Means for that purpose we can go to whatever extent, good or bad. Now what I say when I'm saying communication and coordination, this means I have to talk about professional world, and that is here. I worked concrete, then we talked of grades of concrete, and durability requirement. So we were here, let's say I have gone through slump etc. You remember? Let's now stay somewhere. Was talking about temperature of concrete. Now we talk of, let's go back and discuss. It's 43 page of this 205 page file. We talked of temperature. It is a 5 and 32 degrees Celsius. We studied that one, and then we went to various classes of the sulfate exposure classes, and you can say exposure classes of reinforced corrosion, and before that corrosion etc. we talked of. Now we have about fresh concrete. What does it say? What is fresh concrete? What does it mean? How does it work? Temperature controls we have to go through that. Otherwise we have known everything. So just for a little overlap of previous work, where adequate workability is difficult to obtain at maximum water cement ratio allowed, use of plasticizers or water reducing admixtures may be considered. Alternatively, an increase in cementitious content may be considered where there shall not adversely affect durability of concrete. Cementitious contents in excess of 400 kg per cubic meter shall not be used unless a special consideration has been given to effect for heat of hydration and reduce thermal stresses in concrete, and approval has been obtained from engineer. Maximum cementitious now. Proportioning, mixing and placing of mixture shall be done in accordance with whatever parts of the specification we'll see later on. Issue of temperature is very important. Maximum fresh concrete temperature shall not exceed 32 degrees Celsius unless construction testing to verify a proposed concrete mixture function satisfactorily shall function satisfactorily at a concrete temperature greater than 32 degrees Celsius. No concrete shall be placed if temperature concrete temperature is above 35 degrees Celsius. So limit is, you can say tolerance limit is from 32 degrees Celsius to 35 degrees Celsius. Means no way you should concrete when its temperature is more than 35, but normal limit is 32 degrees Celsius. And lower limit is not given here, but that is 4 degrees to 32 degrees. For massive concrete producers shall demonstrate that temperature of concrete due to hydration do comply with maximum fresh concrete temperature that is specified. Supplier may use in its demonstration testing heat sensors and simulation technologies which measure concrete heat of hydration and cannot do anything. So you can say contractor is responsible for ensuring that concrete is able to be fully compacted within concrete element regardless of reinforcing density or other limitations. This may involve reducing maximum aggregate size, increase in level of concrete workability, or use self-compacting concrete. Where consistency of concrete is to be determined, it shall be measured either by means of slump test or flow table test. Consistency of concrete shall be determined at time of use of concrete, in case of ready-mix concrete at time of delivery. Tolerance for different consistencies are as follows. Slump is given here, you can see, and of course flow diameter is given. Certain temperature requirements of concrete. Now we have to find various grades of concrete. You know them, but because now we are reviewing this document, so we have to of course refer. Grades of concrete mean various. Grade means strength of concrete, that is compressive strength of concrete. In fact, where strength is classified with respect to compressive strength. This table which have here is used in certain proportions, we can say. We have to make it a reference only. Currently is temporary reference. Characteristic compressive strength. Characteristic compressive strength at 28 days of 150 cubes, that is represented FCK cube, or 150 diameter by 300 cylinders, that is FCK cylinder, may be used for classification. Exception shall be made for concrete mixtures containing fly ash, silica fume, or GGBS, where testing be requested at 56 days or 90 days as approved. Now, what are these grades? As a column table, you can say concrete grade, that is B15 to 75, C75, then minimum characteristic strength, maximum characteristic cylinder strength, minimum cementitious content, and minimum water cement ratios. These are given here. Cement content never increase 390 here, you can say 400 is maximum limit. And as you know, concrete grade is higher, it goes on in increasing from B15 to C75. You can say water cement ratio goes on decreasing. That is main, and content of cement goes increasing. For example, in C25 it is 260 kilogram per cubic meter. In C75 it is 390 only, means not much different. But water goes on falling, you see, quantity of water goes on falling from 0.6 to 0.35, and this is where variation lies. And you can review this table yourself, because this is very nominal engineering. Durability requirement. Now, durability comes into play when you talk of something which is very important, durability. And durability, as I said, it should continue for long distance travel, long time to travel with same resistance that it starts with. When you produce concrete, what resistance you get in 28 days, or you can say 90 days, or 60 days, or 58 days. It should continue with further improvement rather than saying same, but let us say it's same. It should continue for how many number of years this has to live, this has to serve. I am saying live because this is a living being for me. It is functional, it's not dead item. So we call it that weight is dead, but function is not dead. Live actions apply, wind applies, or you can seismic action applies. Dead load is already there, but it's not only load, there are so many other loads on that work forever enough. You can see round clock, we cannot stop that. Durability, that was we say, constituent materials shall not contain harmful ingredients. First question is, and first answer is, what is durability? Its requirement is constituent materials shall not contain harmful ingredients in such quantities as may be detrimental to concrete durability or cause corrosion of reinforcement. ऐसा कोई भी नहीं होंगे जिससे उसकी लाइफ कम हो जाए कंक्रीट की, या सरिये में जंग लग जाए, रस्ट हो जाए. Constituent materials shall not contain harmful ingredients in such quantities as may be detrimental to durability of concrete, or cause corrosion of reinforcement. For reinforced concrete in ground, Requirement for protection from chlorides must be balanced against the need for protection from sulfates. Protective measures include use of surface treatment, I mean to say concrete surface treatment, alternative reinforcement and increasing concrete cover in heavy and we have seen acid chlorides, maximum acid soluble chloride contents, and we have talked about this already. It is calcium chloride, and of course it is calcium chloride, if we can say. Again, same problem of singles. Chloride content of concrete expressed as percentage of chloride ions by mass of cementitious material. By mass of cementitious material shall not exceed value given in this table. Calcium chloride and chloride based admixtures, you can say calcium chloride and chloride based admixtures shall not be used in concrete containing steel reinforcement or other embedded metal. पाँच बजने वाले हैं, बजे नहीं है, 4:45 बजे, 5 बजने वाले हैं, बजे नहीं है अभी, सो जा क्यों उठ रही है, क्या टॉयलेट जाएगी तो calcium chloride and chloride based admixtures shall not be used in concrete containing steel reinforcement or other embedded metal. Determination of chloride content. Determination of chloride content in concrete shall be conducted by sum of contributions from constituent materials as described herein. Now, as a table, it says concrete type. First of all, it says it's concrete type, then concrete made with sulfate resisting Portland cement, and then concrete made with other cementitious materials, then SRPCs, that's sulfurizing Portland cement. Other than that, it talks so reinforced concrete when made of SRC, it's 0.15% permissible, is maximum chloride content, and if it is of sulfur resistant cement other than that, I mean to say it's cementitious materials like based on supplementary cementing material, it is 0.3%, means it can take double, while his precious concrete almost the same, means 0.08%, because half of what we take in ordinary reinforced concrete, and then here it can take more than that. Type of cementitious materials, different types of you can say cementitious materials offer different resistances to sulfate attacks and penetration of chlorides. Minimum cementitious content for different concrete grades given table. Then we can see this table. Cement materials likewise. Portland cement, is already given. We have gone through Portland cement type 1 itself. SRC is type 2. So here, there is no cementing material. I mean to say supplementary cementing material is no use there. Ordinary cement is there. Portland cement, percentage components 100% PC. Likewise, we have to see about this fly ash and PC, combination of various grades here. We have gone through that before, but if it is all, you can say 65 to 79% PC Portland cement, then you can say fly ash can be 35 to 21. With PC and GGBS, that is PCS 35 65 and GGBS is 65 to 35. This is the combination, and you also can say otherwise triple blend. We have PC and fly ash and SF, silica fumes SF, micro silica, you can say, and these three are their PCs 55 to 70, fly ash is 35 25, silica few microsilica is 10 to 5. This combination, and this is another one, that's triple band. PCGGBS have, I mean, no fly ash in that case. PC is 3545, GGBS 650, and SF is 5. In fact, generally up to, you can say, 30 C, 30 Portland cement and 70 GGBS are used. Resistance to alkali silica reaction. Alkali silica reaction is most common form of alkali aggregate reaction. Alkali aggregate reaction. Dry concrete is not prone to cracking. Here's the point. Dry concrete is not prone to cracking. Dry concrete is not prone to cracking by alkali silica reaction, as it requires an external source of water to develop sufficiently to cause cracking. Where aggregate contains variety of silica susceptible to attack by alkalis from cement and other sources, and concrete is exposed to humid conditions, actions shall be taken to prevent deleterious alkali silica reaction using recommendations and procedures given in BS. These BS are here. So it says where aggregate contain varieties of silica susceptible to attack by alkalis from cement and other sources, and concrete is exposed to humid conditions, action shall be taken to prevent deleterious alkali silica reactions. Again I say, where aggregate contains a variety of silica susceptible to attack by alkalis from cement and other sources, and concrete is exposed to humid conditions, action shall be taken to prevent deleterious alkali silica reaction. It's called alkali silica reaction because aggregate contains silica that can be attacked by alkalis. Now we have to resist corrosion. We have to resist corrosion and durability of concrete. Durability design should start at concept design stage, continuing through design, detailing, specification and execution phases. Now, this section covers concrete grade, cementitious type and minimum concrete cover for various exposures. Here is, you can say, certain covers are given in all classes of here concrete X1, X2, X3, the exposure classes. This is 5 exposure classes. No risk of corrosion. Here is mild and moderate, aggressive, severe and extreme. These are given here. This we have to clearly understand in our way. And you can say in mild, from mild stage, or you can say from moderate to extreme stage, you see cover thickness here. It is, different types of concrete grades here. Higher grades means lesser cover, lower grade means higher cover. Have that. And what combination of this cement is given here. You can see that. We can go through this. Already we have discussed this. And it's the higher level of cement replacement. High level of cement replacement, that is here in this case, is required for severe and extreme exposure conditions. High level of cement replacement is required for severe and extreme exposure conditions. Other protection measures such as coated reinforcement or you can say epoxy coated reinforcement or surface treatment may be considered. So this gives some idea, means what thickness of cover can be taken for purpose of good durability, and how much cement, what percentage of cement or OPC can be replaced by GGBS, let us say. And sometimes we have used, as I said, up to 70% replacement of OPC to resist sulfate attack. How to resist sulfate attack? That is exposure classification. Exposure classification shall be identified based on sulfate and magnesium contents. You can say exposure classes shall be identified based on sulfate and magnesium content on ground and groundwater. Ground and groundwater. How much sulfate and magnesium contents are available in ground itself, that means soil and groundwater. What pH and mobility of groundwater as given, let us say what is that. Recommended concrete specification requirements in terms of concrete grade and cement is high given. Now, so unless stated otherwise by engineer or project designs, all concrete below ground shall have surface protection to prevent movement of moisture from ground through foundations into superstructure. Method of protection shall be in accordance as given in other standards. Now, what is recommended durability requirement to resist sulfate attacks? Here is the S1 is sulfate 1, sulfate like 5 classes, and it's in 5. S5 requires special treatment when sulfate content exceeds 6000 mg per liter and the magnesium content exceeds 1000 mg per liter. Sulfate is 6000 milligram per liter and magnesium is 1000 milligram per liter. Concrete grade is C35 minimum in lower exposure case, while it goes on increasing up to S4 with variations. You can say S1 is 35, S2 is 40-50, S3 is 50-60, S4 is 60-75. And we can say in first case, that is S1, all can be used, all cement, but in other cases there are blending with, you can say SRC, FPC, FPPA likewise. Durability related properties. Durability of concrete is greatly influenced by ability of concrete cover to resist movement of liquid and gas through concrete. Got it? Durability of concrete is greatly influenced by ability of concrete cover to resist movement of liquid and gases. Commonly used tests for assessment transport properties of concrete are given in this table. Let's see that one. No values are currently specified for various exposure classes, but may be requested by engineers. So now for severe and column, test method, then high durability and minimum durability. First item is water absorption. In high durability 2% absorption and in minimum durability 4%. Water penetration 5 mm in high durability and 30 mm in minimum durability. Rapid chloride permeability RCP is 500 columns only in high durability, while up to 4,000 columns minimum. The column is a unit of rapid chloride measurement. Chloride migration is 2 into 10 to power minus 12, or you can say 2 over 10 to power 12. Same way, minimum durability case is 9 into 10 to power minus 12 meters square per second. Concrete shall be tested for whatever of transport properties when requested by engineers, and at 28 days. Exception be made for concrete mixtures containing fly ash, silica, fume or GGBS when testing requested at 56 days or design of concrete mixes. Whenever you start construction period, whenever you start some construction, then contractor should design a mix for each grade of concrete. Each mix shall be such that each mix design shall be such that aggregate shall comprise fine and coarse with size specified. Combined aggregate grading be continuous. Aggregate quantity be calculated by weight, not by volume. So there are three conditions. Aggregate comprise fine and coarse aggregates. Combined aggregate grading be continuous. Aggregate quantity be calculated by weight. Where a concrete production facility has a strength test on records for more than 12 months, a sample standard deviation can be checked out. Test records from which calculated and consists of this 30 consecutive tests or group of consecutive tests totaling to at least 30. And where it's not available, where a concrete product facility does not have a strength test, then we can use some factors, and that is given in this table. If it is less than 15 number of tests, then we can say use para 7 below. We'll see what is that. Then it's 15, 20, 25, 30. We can use these coefficients here, modification factor for sample standard deviations. It's given noting the interpolate for intermediate number of tests, modified sample standard deviation to be used to determine required average strength. To determine correction factor between cube strength and cylinder strength, current contractor establishes at least 30 consecutive strength tests from each proposed mix. This correction remain valid through project, providing that no change in properties of material and no change in source occurred. Required average compressive strength, target mean strength used as basis for selection of concrete proportions shall be determined here. Now, required target mean strength when data are available to establish a sample standard deviation. Here's column number 1 says specified compressive strength. It's Newton per meter square or MPa. And this megapascal is required is average compressive strength, target mean strength, Newton per meter square or megapascal. So this one is, in this case, specified one is F-C, that is compressive strength, less than or equal to 35 MPa. Here we can say use larger value computed from an equation of success. In other case it is F-C is equal to F-CR is equal to required average compressive strength, target mean value of strength. This is F-C plus 1.34 SS standard deviation, 1.34 standard deviation. That's equation 1. And other one is F-C plus 2.33 SS minus 3.5. That is equation 2 in this case. So it is like that. When it's case of F-C greater than 35 MPa, in that case F-CR is equal to F-C plus 1.34 SS as before, and here is also F-CR, that is 0.9 F-C. Now we apply 10% reduction factor here, that is 90.9 FC plus 2.33 S, and that's the number. When a concrete production facility does not have field strength test records for calculation of SS, required average strength, target mean strength, F-CR shall be determined as follows, and that is F-CR is equal to F-C plus 8.5 MPa. When 20 is less than F-C is less than 35, means in range of 20 and 35, we can use this formula, F-C plus 8.5 MPa. And when it uses 1.1 F-C plus 5 MPa, when F-C is greater than 35 MPa. So this is formula for correction, we have to understand this point of reaction. This is required table for mean strength, required target mean strength, when data are available. Portland cement concrete shall consist of mixture of cementitious materials, fine aggregate, coarse aggregate, water and additives. Portland cement concrete shall consist of mixture of cementitious materials, fine aggregate, coarse aggregate, water and additives when required. It shall be classified unless otherwise stated herein after. Blinding concrete. Blinding concrete. It shall be minimum grade 15 and above, not below 15. This is blinding concrete. I know you know what's blinding concrete. We call in India this lean concrete, but this means this is non-structural concrete on which our foundations rest. Blinding concrete. Thickness of blinding concrete shall be as shown on drawings, but in no instance less than 75. So minimum is 75 mm. Surface finish to blinding concrete is class 4. U4 as specified in this section 9, part 9 of this section. So that we'll see. I mean to say it's not very much finished, but ordinary finish, so that you. Now, what is other one is mass concrete. Mass concrete. It's massive concrete, in fact. Mass concrete, fresh concrete temperature. Fresh concrete temperature at placing shall not exceed 21 degrees Celsius. So this is given here. Massive concrete temperature. Massive concrete is a big item. It is big foundation, which is size of one minimum size is more than 0.8 meter, and quantity of concrete is much more than 8 cubic meter. Fresh concrete temperature in this case should be 21 degrees Celsius. It should not exceed that. To minimize thermal cracking has to be minimized. Higher temperature up to 27 degrees may be accepted with demonstration of satisfactory performance of concrete, including mock-up. And thermal calculations. Maximum allowable differential temperature between interior and exterior of mass concrete. Interior and exterior of mass concrete element shall not exceed 20 degrees. It's a point of concern. This point should be noted properly, and this is very much professional point. Internal and external. Internal and external mass concrete difference of temperature shall not exceed 20 degrees Celsius. Maximum temperature in whatever location within mass concrete structure during curing shall not exceed 70 degrees. Maximum temperature in whatever location shall not exceed 70 degrees Celsius. Drop in concrete surface temperature during and at conclusion of specified curing period shall not exceed 11 degrees Celsius in 24 hours period. So how many temperature coefficients, how many temperature pounds we have here? Concrete temperature should be between 5 or 4 degrees to 32 degrees. That is first criteria in ordinary concrete. It should never be more than 35 degrees Celsius in ordinary concrete. When we use supplementary cementing material based concrete like PFA, GGBS, microsilica or a triple band. In that case, it should not be more than 21 degrees Celsius and maximum up to 27 degrees Celsius, provided demonstration has been made satisfactorily for required performance of concrete, and that is based on mock-up and thermal cracking thermal calculations. That's another point, or we can say differential temperature in mass concrete, and that means internal temperature and external temperatures should not be more than 20 degrees Celsius. And in any location or whatever location of that mass, it should not exceed 70 degrees Celsius. Means internal temperatures are higher in this case, and you can say external is dependent on weather conditions. We can say drop in concrete temperature, concrete surface temperature drop, you can say during conclusion of curing period should not exceed 11 degrees in whatever 24 hours. That is drop in concrete temperature. So many points. First is ordinary temperature, that's 5 to 32. Then massive concrete, that's 21 or 27 in between, and we take 24 degrees Celsius. Then it is temperature difference between internal and external temperature. That is, difference should not be more than 20 degrees. Say external temperature is say 40 degrees, then it should not be more than 60 inside. Maximum temperature in whatever location is 70 degrees at conclusion. 70 degrees maximum one, and also concrete temperature drop on surface of concrete, and that is when your concrete curing is almost over and should not exceed 11 degrees Celsius drop in concrete surface temperature in 24 hours. 11 in concrete, we have to understand it clearly, otherwise it shall be a problem. Now, self-compacting concrete. General self-compacting concrete is a special concrete that requires minimum, or you can say no vibration, for placement or placing and compaction. It's able to flow under its own weight, completely filling from work and achieving full compaction, even in presence of congested reinforcement. hardened concrete is dense, homogeneous, and has same engineering properties and durability as traditional vibrated fully compacted concrete. Good paragraph. Self-compacting concrete SCC is a special concrete that requires minimum or no vibration for placing and compaction. It's able to flow under its own weight, completely filling formwork and achieving full compaction even in presence of congested reinforcement. Hardened concrete is dense, homogeneous, and has same engineering properties and durability as traditional vibrated fully compacted concrete. Self-compacting concrete supplier shall be supplied SCC shall be supplied by a competent concrete producer with a record of successfully producing this type of concrete at considerable volume and with constituent materials for self-compacting concrete are same as those used in traditional concrete. Achieve these requirements, control of constituent materials need be increased and tolerable variations restricted so that production of SCC is within conformity criteria without requirement to test or adjust every batch. Recommended test requirement for SCC. One is slump flow, other is V funnel, L box and J-ring. Slump flow is laboratory and field both. We have in laboratory 600 to 750 mm slump flow. Field test is 550 mm to 750 mm. V funnel 6 to 25 seconds. It takes 6 to 25 seconds. Field test not applicable. L box T bars 3 bars greater than 0.8 and not applicable in field. J ring is also less than equal to 10 mm and field test not applicable. Concrete specimen shall be molded. See, in this case slump flow is quite 600 to 750 means it tells how flowable it is. Slump flow, see, concrete specimen shall be molded in single layer without rodding and tapping. Concrete specimen shall be molded in single layer without rodding and tapping. Slump flow and VSI testing shall be performed in as outlined in various guidelines of SCC in various codes. Pile concrete. Cementitious content shall not be less than 380 kg per cubic meter. 380 kg minimum. Water cementitious ratio shall not exceed 0.45. So here's a very important point. Maximum cement content is 380 kg per cubic meter and water cementitious ratio not to exceed 0.45. Concrete mixture shall be designed of high slump. Concrete mixture shall be designed of high slump, not less than 150 mm, allowing proper free fall with excellent homogeneity. When concrete mixture requires lump of greater than 30 mm, it shall be designed as self-compacting concrete. And when slump concrete mixture requires slump above 230 mm. So it is self-compacting concrete. Concrete pump, concrete slump shall have adequate workability, retention using approved type of retarder and up. Increase concrete slump shall have adequate workability, retention using approved type of retarder and shall be submitted in design mix. Increase in workability shall not permit any decrease in specified design strength. Design strength should remain same. Then we have concrete in pile, if at all possible, be placed in one continuous operation. Since increase in workability shall not permit any decrease in specified design strength. Increase in workability shall not permit any decrease in specified design strength. Concrete is pile underwater concrete. It shall comply with ACI chapter 8 304 shall comply this underwater concrete. Cementitious content shall not be less than 390 per kilogram per meter cube. It's more 10 gram, 10 gram. Generally specified. That is air contents 5% up to 5% and fine aggregate contents 45 to 55%. Concrete shall be more cohesive. Concrete shall be more cohesive and less prone to washout of cement or fines from concrete. This means slurry should not go out. During placing, anti-washout admixture or alternative concrete mix shall be used for underwater concrete. I repeat, concrete shall be more cohesive and less prone to washout of cement or fines from concrete during placement. Anti-wash admixture or alternatively trial placements shall be conducted To verify that concrete proportioned trial placement shall be conducted to verify concrete proportioned with anti-wash mixture and mixture of propolis. You can say trial placement shall be conducted to verify concrete proportion with anti-wash and mixture can maintain adequate slump life and can flow for required distance. Concrete mixture shall be designed of high slump, not less than 150 mm, allowing proper free fall with excellent homogeneity. Use of air entraining mixture shall be evaluated as it increases workability when concrete mixture you can say concrete mixture shall be designed of high slump and not less than 150 mm, allowing proper free fall with excellent homogeneity. You can see use of air entraining admixture shall be evaluated as it increases workability. Use of air entraining admixture shall be evaluated as it increases workability. When concrete mixture requires slump of greater than 230 mm, it shall be designed as self-compacted concrete. Increase in slump shall be made using proper admixtures. Concrete slump shall have adequate retention using approved type of retarder and shall be submitted in design mix. Concrete slump shall have adequate retention using approved type of retarder and be submitted in design mix. Increase in workability. Increase in workability shall not permit any decrease in specified design strength. Concrete shall be placed in one continuous operation. Final selection of a concrete mixture. Final selection of concrete. Concrete shall be placed in one continuous operation. Final selection of concrete mixture shall be based on test placement made under water in a placement box in a pit that can be dewatered after placement. Test placement shall be examined for concrete surface fitness, concrete surface flatness, amount of latency present, quantity of concrete at extreme flow distance of test and flow around avoid items if appropriate. Shotcrete. Classification of shotcrete should be in accordance to process used, wet mix or dry mix, and size of aggregates used. All materials should be per steel and synthetic fibers shall be used to reduce propagation of cracks. Steel and synthetic fibers shall be used to reduce propagation of cracks. Fibers shall be according to manufacturer supplier data sheet and conform to ASTM 820, A820, A820 steel fiber and ASTM C1116 ASTM synthetic fiber. Now you can say nozzle operator. Nozzle operator should be certified. First of all, we have to see nozzle because it's shotcrete. Nozzle operator should be certified and have completed at least one similar application as nozzle operator on a similar project. Nozzle operator should also be able to demonstrate nozzle operator should be certified and have completed at least one similar application as a nozzle operator on a similar project. Nozzle operator should also be able to demonstrate by test and ability to satisfactorily perform required duties and to apply shotcrete as required by specification. Before shotcrete and maintained before and during concrete shotcrete application, surface preparation shall conform to this code ASCI 506R chapter 5. Cementitious content shall not be less than 360 kg per cubic meter in case of shotcrete. When wet mix is applied, no slump shall be in range of 40 to 80 mm. Normal testing ages for compressive strength are 7 and 28 days. However, shorter period may be added. Now begins that normal testing ages for compressive strength are 7 and 28 days. However, shorter periods may be required for particular applications or conditions as directed by engineer. Testing shall be on daily production or every 30 cubic meters, whichever is greater. And testing, however, should be varied according to size. Sampling and testing, however, should be varied according to size and complexity of project. Sampling should be done in accordance with ASTM C1385. Making extra cylinders or panels shall be at request of engineer if testing results vary. Testing for water absorption and drying shrinkage shall be at request of engineer. Fiber reinforced shotcrete requires fiber washout tests or flexural toughness tests. Acceptance of shotcrete should be based on results obtained from drilled cores or sawed cubes. Use of data from non-destructive testing devices such as impact hammer or probes, ultrasonic equipment, and pull-out devices may be useful in determining uniformity and quality of in-place shotcrete. Uniformity and quality of in-place shotcrete. These tests, however, may not provide reliable values for compressive stress. Used to evaluate encasement of reinforcement. Core grading is a method used to evaluate encasement of reinforcement. A core grading shall be used for nozzle operator evaluation. Core grading should not be used to evaluate structure. Core grading is a method used to evaluate encasement of reinforcement. No fines concrete and pervious concrete. No fines concrete and pervious concrete. No fines concrete. No fines concrete shall be made using a coarse aggregate conforming QCS section 5. No fines concrete shall be made using a coarse aggregate. Proportion of aggregate, cement and water shall be determined by no fines concrete shall be made using a coarse aggregate. Proportion of aggregate, cement and water shall be determined by trial mixes by contractor and to be accepted by engineers. No fines concrete shall be made using a coarse aggregate. Proportion of aggregate, cement, water shall be determined by trial mixes by contractor and be replaced accepted by engineers. All aggregate particles to be coated with a film of cement grout. All aggregate particles to be coated with a film of cement grout. No fines concrete when placed shall contain no layers of latents. When placed shall contain no layers of latent. No fines concrete shall not be mixed by hand. Mechanical vibration shall not be used to compact no fines concrete. 3 test cubes of no fines concrete shall be made with each preliminary mix. Minimum crushing strength of chosen mix shall be 5 MPa on 21 test. No fines concrete when placed shall contain no layers of latents. No fine concrete shall not be mixed by hand. Mechanical vibration shall not be used to compact no fine concrete. 3 test cubes of no fine concrete shall be made of each preliminary mix. Minimum crushing strength we can say then minimum crushing strength of chosen mix shall be 5 and 28 days. We can say mechanical vibration shall not be used to compact no fine concrete. 3 test cubes of no fine concrete shall be made of each preliminary mix. Minimum crushing strength of chosen mix shall be 5 m at 28 days. Here, porosity. Porosity of no fines concrete shall be such that water pass through a slab 300 mm thick at rate of not less than 71 liter 7 liters. I mean say 71 per meter square. Porosity of no fines concrete shall be such that water pass through a slab 300 mm thick at rate of not less than 71 per meter square. 7 liter per meter square. Some error is there, I think. 7 liter per square meter of slab with a constant 100 mm depth of water on slab. On slab 300 thick, put 100 mm water, and then you see how does it work in filtration or corrosion, as you can say, how automatically it works. Where is slab incorporating vertical sweep holes. Here slab is incorporating vertical sweep holes or drain holes is cast above a layer of no fines concrete. Polythene sheeting shall be pierced below pipe forming such drain holes and edge of sheeting sealed to lower end of pipe to prevent ingress of grout and fine particles from slab concrete into no fines concrete. Limit for maximum height of drop while placing is not applicable for no fines concrete. No limit of maximum height. Limit for maximum height of drop. Limit for maximum height of drop while placing is not applicable for no fines concrete. Formwork shall not Formwork shall remain in place until no fines concrete has gained adequate strength to support itself. Curing shall be carried out in accordance with provisions of Part 11. You can say limit of maximum height of drop while placing is not applicable for no fines concrete. Formwork shall remain in force until no fine concrete has gained adequate strength to support itself. Curing shall be carried out in accordance with provisions of Part 11 as well. Fresh density of previous concrete shall be tested and infiltration from now fresh curing shall be carried out the same way, and fresh density of pervious concrete shall be tested and inflation rate tested, and to follow this testing and quality control scheme. Concrete with recycled aggregate of recycled aggregate is identified based on type and approved by engineers. Recycled aggregate shall meet QS requirement. What's the requirement? We'll include that. Okay, that's normal one. BSCN 12620 and QCS requirements. Concrete made with recycled aggregates shall be limited to design strength of C40 MPa cube strength unless otherwise accepted by engineers. Shall be water cement ratio shall not exceed water cement ratio shall not exceed 0.5. Determine target mean strength on basis of a required strength. To determine a target mean strength on basis of a required strength, a higher standard deviation increased by 40% shall be used when designing a concrete with recycled aggregate of variable quality than when recycled aggregate of uniform quality or virgin aggregates. To determine a target mean strength on basis of required strength, a higher standard deviation increased by 40% shall be used when designing a concrete with recycled aggregate or variable Now, said that specific will determine target mean strength on basis of required strength. Higher strength division 40% higher shall be used when designing concrete with recycled aggregate of variable quality than when recycled aggregate of uniform quality or virgin aggregates are used. Specific gravity, unit weight, and absorption of aggregates should be determined before mixture proportion studies. Mixture proportion should be based on measured density of recycled aggregates intended on in this job, in whatever job, concrete. Trial mixes shall be made. Trial mixes shall be made to verify required. Important item, heavyweight. Heavyweight and relation shielding concrete. Quality of aggregate should comply with requirements of QCS. Quality of aggregate should comply with requirement of QCS for normal weight concrete aggregates. Quality of aggregate should comply with requirements of QCS for normal weight aggregate. ASTM C637 for heavy weight aggregate and ASTM 638 for aggregates to be used in radiation shielding concrete. When ferrophosphorus aggregates are used, ferrophosphorus aggregates are used, tests should be made to ensure this. We can say when ferrophosphorus aggregates are used, tests shall be made to determine if gases that is non-toxic might be released during construction. Aggregate shall be checked for every delivery to ensure deleterious substances. Chemical aggregates shall be frequently evaluated for effects of deleterious substances or aggregate coatings on concrete strength or promotion of corrosion in metallic aggregates or embedments. Promotion of corrosion in metallic aggregates or embedments. Chemical properties of all high density aggregates must be provided to engineer for evaluation before use. Chemical properties of high density aggregates must be provided to engineer for evaluation before use, with due consideration given to chemical reactivity, particularly in cases of reactions. Chemical properties of high density aggregate must be provided to engineer for evaluation before use, with due consideration given to chemical reactivity, particularly in highly alkaline highly alkaline environment as found in cement paste. Test for alkali aggregate activity shall be determined from iron Tests for alkali aggregate activity shall be determined from each source and supplier and be made every 3 months. Fresh density of high density concrete shall be made from each truck. Lead short concrete, lead short concrete shall not be used for structural work. Density, strength as well as other hardened concrete properties shall be tested and verified before use of concrete. Thermal conductivity, elastic behavior and shrinkage hardened concrete. Relax. Now, fiber is a lead short concrete shall not be used for structural activity. It is a thermal conductivity, elastic behavior, and shrinkage, hardened, hardened density, strength, density of strength. No, concrete. Classification of fiber reinforced concrete shall be made based on material type of fiber incorporated. What type of fiber we have used in concrete, it shall depend upon that. Classification of fiber reinforcement shall be made based on material types of fiber reinforcement. Type 1 is steel fiber. Type 2 is glass fiber, RC or GFRC, glass fiber reinforced concrete, and third is synthetic fiber reinforced concrete and natural fiber reinforced concrete. Steel fiber, that's type 1, that is steel fiber reinforced concrete, contains stainless steel, alloy steel or carbon steel fibers conforming to specification BSEN 14889-1 or ASTM A20 or A20M. So this type 1 steel fiber reinforced concrete contains stainless steel, alloy steel or carbon steel fibers. Type 2 glass fiber reinforced concrete. Glass fiber reinforced concrete contains alkali resistant glass fibers conforming to specification C1 666 C or 1666N. Type 2, there is glass fiber that is Glass fiber reinforced contains alkali resistant glass fibers conforming to specification. Now, type 3 synthetic fiber reinforced concrete contains synthetic fibers for which documentary evidence can be produced, confirming their long-term resistance to deterioration when in contact with moisture and alkalis present. In cement paste and substances present in admixture are type 3 synthetic fiber reinforced concrete contains synthetic fibers for which documentary evidence can be produced, confirming their long-term resistance to deterioration when in contact with moisture and alkali present in cement paste and substances present in a mixture and conform to BCN 1489-2. We can say synthetic fiber, as I said, contains synthetic fibers which document evidence can be produced, confirming their long-term resistance to deterioration when in contact with moisture, and alkali is present in cement present paste and substances present in admixture and shall confirm for which documentary evidence can be produced, confirming their long-term resistance to deterioration when in contact with moisture and alkalis present in cement paste and substances present in admixtures. Test method is TMTD 6942 shall be used to determine susceptibility of these fibers to deterioration as a result of exposure to alkalis and concrete. When purchaser chooses to permit use of fibers, when purchaser permits when purchaser chooses to permit use of fibers other than those complying with above classifications, manufacturer or supplier shall show evidence satisfactory to purchaser that type of fiber proposed for use show long-term resistance to deterioration when in contact with moisture and alkalines. Yes. When purchaser chooses to permit use of fibers other than those complying with above classifications, manufacturer or supplier shall show evidence satisfactory to purchaser that such type of fiber proposed use show long-term resistance to deterioration when in contact with moisture and alkalis present in cement paste and substances present in admixture. Contractor shall submit type of fiber slump or time of flow slump or time of flow required at point of delivery or appropriate point of placement, subject to tolerances. Hereinafter, specified slump shall be specified when it is anticipated to be 50 or more, except as otherwise specifically permitted by engineer. Cement, supplementary cementitious material, fine and coarse aggregates, mixing water and admixtures shall be measured in accordance with applicable requirements of QCS. Fiber shall be measured by mass. When fibers are to be measured by mass, bags, boxes, or like containers are acceptable, provided that such like containers uh, you can say fibers shall be measured by mass. When fibers are to be measured by mass, bags, boxes, or like containers are acceptable, provided that such like containers are sealed by fiber. Mhm. So we can go on, read this for a couple of minutes. Meanwhile, I'll be back in a momentary way. If it continues, we'll talk. Okay. What is that? This important, and more, except as otherwise specifically permitted by engineers. Cement delivery or when appropriate point of placement. Subject to tolerances, their specified slump shall be specified when it is anticipated to be 50 mm or more, except as otherwise specifically permitted by engineers. Cement supplementary cementitious materials, fine and coarse aggregates, mixing water and admixtures. Including fibers shall comply with packing, packaging and marking requirements of specifications ASTM 387, RC1480 and be accepted for use provided that Manufacturer of fiber reinforced concrete shall furnish to purchaser a delivery ticket or statement of particulars on which is printed, stamped, or written information details of type, brand, and amount of fibers used. Contract shall afford inspector all reasonable access without charge for procurement of samples of freshly mixed fiber reinforced concrete at time of placement to determine compliance with requirement of this specification. Samples of batch mixed fiber reinforced concrete shall be obtained in accordance with practice for shotcrete as appropriate, except that wet sitting, wet sieving shall not be permitted. Sampling for uniformity tests shall be fall outside limits permitted by this specification. Make a check test immediately on another portion of same sample. If results again fall outside permitted limits, materials represented by samples fails to meet requirements. Following shall apply to all forms of fiber reinforced concrete except dry mix shotcrete. Time of flow shall be in tolerance as follows: when project specifications for time of flow are written as minimum or not less than requirement, plus tolerance in specified times of flow 15 seconds or less, 6 or more, 5 as 10 as, and minus tolerance.